This talk is called Service Mesh Patterns, just in case you're in a wrong room. My name is Peter. I'm a consulting member of technical staff. Anyone cares to guess what that is? No, I'm just a developer. It's nothing special. But Oracle likes to give us nice titles so we can brag. But anyway, I'm a developer working at Oracle. I work on the serverless framework called the FN project. Before Oracle, I spent around 10 or 11 years working at Microsoft. And in the past couple of years, I've been focusing mostly on cloud native, on Kubernetes, microservices, and service meshes. And this is what this talk is about today. How many of you have been here for the previous talk? All right, well, guess what? We're going to talk about microservices again. Have you heard about microservices before? Yeah? How many of you heard about microservices today? How many of you heard about microservices in the past hour? It's the point I'm trying to make. It's very popular and it's a big deal. I'll talk about microservices briefly as well. I'm not going to spend too much time on the theory, though. I'll just give you a quick overview, and I'll be mostly focusing on things that are around microservices and show you how service mesh can help you. So if you have an existing monolith today and you decide to start breaking it down into multiple components or microservices, you'll quickly notice that previously you had this big, giant, monolithic thing, and now all of a sudden you have multiple smaller things that also need to be managed. You previously had probably one single code base, you had a single monolithic deployment, and now all of a sudden there's multiple deployments, there's multiple code bases, and all these different components that need to work together. In addition to this, once you move to this microservices architecture, you're probably not running a single instance of a service. You're running multiple instances of this service, right? All this makes stuff a little bit more complicated. So in so many instances, there's a lot of things that you need to figure out. Deployment is one of them. So how do you deploy all these instances and all these components to all of these VMs that you have running there? One way is there's a command called SSH, and you can go into each single machine and you can go and deploy it. But that doesn't really make sense. So you need some orchestration tools to do that. And this is where Docker and Kubernetes come into play. You've heard of Docker, yes? Perfect, oh, perfect. Okay, so with Docker, you just package up your application into a nice small image, and then you can use that image, give it to Kubernetes, and Kubernetes will make sure that your deployments are evenly distributed across all the VMs. And not only that, it will also give you a way, or it will do a health check for your services. So in case your service fails, or if it crashes, what it will do, it will just go and it will restart your container. So this is really nice. Any one of you using Kubernetes already? Yeah, a couple. Perfect. So we're relatively good on the deployment side if you look at it, right? I mean, you still need to manage the deployments and everything, but you have Kubernetes. But with all these different components, there is also a lot of network communication that happens, right, between all these services and different components. And since you have more than one component, the number of connections between services can increase really, really fast. And I'm pretty sure there's like a mathematical formula somewhere. I was never good at math, so I don't know. Otherwise, I would put it on the slide. So if you think about it, it would be really nice if there is something that could help you manage all this communication in a better way. And guess what? This is where service meshes come into play. So service meshes as Istio, as Linkerd, or Console, they can help you out. So what is a service mesh? So the definition says a service mesh is a dedicated infrastructure layer for managing service-to-service communication to make it safe, fast, reliable, and configurable. So it's a lot of nice words and they sound really good. In short, Basically, service mesh deals with everything that happens between the services, with the communication. But how does it work, one might ask? So as an example, let's look at the multiple microservices and how they work together. So regardless of how they get deployed or where they get deployed to, they need to communicate to each other. And what is the simplest way to do that? Well, they talk directly to each other, right? So service A makes a request to service B. It probably needs to set a timeout on the request. It needs to make sure that if the call fails, and if it fails with an error that is retryable, to retry the requests. And if you have multiple versions of service B, it also needs to decide which service to call. And this is just service A, and you probably have a bunch of them, and each service is doing the same thing. So this does not sound too efficient. So how about if we take all this logic, such as retries, timeouts, picking the different versions. What if we take that and move it and push it out of the services? So let's imagine another service that runs next to your service and has all that logic that deals with communication baked in, right? This is pretty much what a service mesh does. So service mesh, and I'll be talking mostly about Istio, but other service meshes they have fairly similar architectures and fairly similar features as well. So what this service mesh does, it puts a so-called sidecar proxy next to each instance of your service. So in previous slide, we saw services talking directly to each other. In this case, it's proxies that are talking to each other. So any incoming or outgoing requests from the services are going through the proxy. So proxy is using the magic of IP tables to intercept all the communication, and it deals with everything, right? In addition, these proxies have configuration, and the configuration is telling them how to route the requests and how should the requests behave. So if we zoom out a little bit and look at the overall picture or the overall architecture, you'll see there's also a collection of so-called control plane services. So the job of this control plane at the bottom is basically, in a nutshell, to take a set of rules that you define. Anyone knows what the rules are defined with? What is the format? There you go, YAML. Yeah, everything, whenever you say like here cloud native, it's usually YAML. So, and everyone loves it. So you take the YAML, the rules that are defined in YAML, and you push them to the control plane. And then control plane takes that information and then pushes it back to the proxies, which is the data plane, right? So in this model, imagine this is the sidecar model, right? The resource consumption can be a big deal and a big problem. The more services you have, you will have basically a proxy that lives next to each of your service instance. So if you're currently running, let's say, 100 services, and let's just for the sake of argument say there's a single replica of each service, well, guess what? Now you already have 200, you doubled, right? So you can see how this can get quickly out of hand. So in addition to this sidecar proxy model, some service meshes also support a so-called per host proxy model. So instead of running an instance of a proxy for each instance of the service, in the per host model, you're running a single proxy per host or per Kubernetes node, and then all the services that are placed on that node, the services that are running on that node, will call through that proxy. So the proxies will still talk to each other, but there won't be a single proxy per service. Instead, there will be a single proxy per node. So this model can pay off, especially if you have like a high number of service instances, or you're constrained with resources, right? Like if you don't have a lot of resources, but you have a lot of services, then yeah, this is a better model to consider. If you've been here for the previous talk, you've probably seen this. Mine is not up to date. There's a galley component missing there. But let's just briefly talk about the service mesh, the Istio service mesh architecture. So Istio service mesh is described as it's an open source service mesh that provides the fundamentals that you need to successfully run a distributed microservices architecture. So per the service mesh definition, it provides you a uniform way to secure, connect, and monitor your services. The mesh is split into two parts. At the bottom part, it's called the control plane. And the upper part, or the collection of all the sidecar proxies, that part is called the data plane. So the control plane consists of all these different components, the pilot, mixer, citadel, and galley. And these components are pretty much responsible for managing and configuring proxies and enforcing policies and collecting telemetry. So let's briefly talk what is a role of each of these components. So Mixer is used to enforce access control and usage policies, basically to prevent one service from calling another service, for example, as well as for collecting telemetry. Because all the communication happens between the proxies, it's pretty easy to intercept and collect all the metrics because of all the requests are passing through the proxies, right? Pilot component. So the purpose of the pilot component is to store an abstract representation of your services or the services in the mesh. And it takes in your nice YAML format. It converts the YAML format to a more abstract and generic representation. And then it uses the Envoy API and converts those rules or that generic model to the Envoy specific config, and then pushes that config down to all the proxies. Finally, Citadel, used for authentication, both into end user and service to service, as well as for authorization control and policy enforcement. As I already mentioned, for its data plane, Istio uses Envoy Proxy. So Envoy Proxy is an open source edge and service proxy. It's designed for cloud native applications. It was developed by Lyft, and it was open sourced by Lyft. It's written in C++. It's really fast. Obviously, Lyft is using it in production. There are other companies that are using it in production, so it is battle tested if you wish. It gets deployed as a sidecar. It sits between the services and intercepts all the traffic. It also can reconfigure itself. So every time Pilot pushes new configuration to it, the proxy will automatically reconfigure itself and read in the new configuration. And finally, you can either inject it manually into your Kubernetes deployments, or you can configure your namespaces and subsequently Istio to have those sidecars injected automatically. All right, so now that we're all familiar with what Istio is, when we know all about it, right? We know how the service mesh looks like. Let's talk a little bit about the features of the mesh and how we can use these features practically, right? So first thing you usually need to figure out is how does the traffic enter your cluster? So Istio, once installed, has a dedicated controller and a resource called gateway. So there's a dedicated ingress controller that's running in the cluster, and there's a gateway which is used to allow traffic to enter the cluster and then direct the traffic to any of the services that are running within your cluster. Similarly, to the ingress controller, there's also a separate controller called egress controller. And what that does is it controls the traffic that's exiting the cluster. And there's also a resource called service entry, which, if you think about it, doesn't really make sense, right? Like, we're talking about traffic exiting the cluster, and the stuff is called entry. But I didn't come up with the name, so service entry it is. But this resource is really nice because what you can do with it, you can use either any external APIs, any external services, any external databases, and you can bring them into your mesh. And you can use traffic routing against them, and you can use all the other features against the external services as you would use between the services that are running inside your cluster. So it's a really nice feature. The next set of features are related to traffic routing. So Istio uses two resources for configuring traffic and how to route traffic. One is called virtual service, and the other one is called destination rule. To give you an example, let's say you want to route traffic to different service versions. Let's say you have your service and you have multiple versions. So the way that you would go about this is, first of all, you need to define what your versions are. And you're going to say, I'll have version 1 and version 2, just to keep it simple. And you define those rules or those versions in the destination rule. Once you have that defined, you can use a virtual service to configure routes and say, for 50% or 20% of whatever percentage of the traffic that's entering the service, I want it to go to version 1, and the rest of the traffic should go to version 2. So this percentage-based or percentage-based routing is also called weighted routing, because you're basically specifying, you're attaching weights to specific routes, and that's how you do the routing. It's very simple, like the weighted routing is fairly simple and easy to understand, but there's also a thing called conditional routing, which means that you can use various properties of the incoming request to decide how you want to route traffic. So for example, you can use a portion of the URL, or you can use headers and header values. You can use a scheme of the URL. You can use the method, right? You can say get post or whatever, go to this version, or you can use, as I said, headers, right? And then route traffic based on that. Security is also a big and important thing, and Istio provides a lot of features around it, such as authentication, authorization, as well as enforcing MTLS, mutual TLS, between all the services, if you turn it on. So the next big section of features are called like resiliency and testing features. And these features can help you make your services more resilient, so you can define like request timeouts and retries and circuit breakers at the mesh level, and that can help you make your services more resilient. So you don't need to necessarily implement these things in each of your service. As I said before, everything is pushed out of the service into this proxy, and it's done there. The second part of the features deals with testing. So service resiliency is important, but you also need a way to test for it, right? So you need a way to force your services to fail and see how those services, as well as any other dependent services and the whole system, how they work together. As an example, you can inject HTTP delays to your services, and basically you can say, whenever I call this service B, I want it to wait for 6 seconds, and then I want it to return after that. So you're simulating network latency. In addition to delays, you can also say, I want this service to return a 404 for 30% of the requests that are coming in. That way you're forcing your services to fail and testing how your system and other services behave. The last, the last section of these features that I would put in under like testing as well, it's called traffic mirroring. So the idea behind traffic mirroring, I think they also call it dark traffic, is to duplicate any production traffic and then send that same request and those same requests to another version of your service that you defined, right? So the thing here is that you're not really routing traffic, right? So your end users are not going to get impacted. You're rather just duplicating or mirroring, as the thing says. You're mirroring the requests and then seeing how your service under test behaves, and you can debug it, and you can do a lot of nice things. But the important thing is you're basically not impacting anything that's running in production. All right, so who's ready for a demo? Not everyone, but yeah? All right, let's do a demo. So I'm going to demo traffic routing. It's a very simple couple of services. They're named very appropriately. I'm very good at naming. The first service is called the Hello Web. It's a simple web front end. And this Hello Web is going to call a so-called greeter service. That's a backend service. And the greeter service is going to return us a greeting. And then the Hello Web will display that greeting. And we'll have initially one version of the service, and then we'll deploy a second version of it, and then we'll slowly crank up and move the traffic from one version to another. So let's do a demo. If I can find my mouse. Okay, there it is. So I do have a cheat sheet, so I don't forget anything. So first of all, I'm running this locally. I have Docker for Mac installed. You could also install Minikube. You could have also used a real cluster, but usually Wi-Fi's and stuff with the real cluster, I'm too afraid to do that. But anyway, so let's deploy the Hello Web. So this is our front end. So as you see, we have 3 instances that are being deployed. Hopefully they'll get up pretty soon. Yeah, they're almost there. Also notice 2/2 here. What that means is there's two containers in this pod, and both of them are ready. And the 2 containers are, first one is our front end, and the second one is the Envoy proxy that we injected automatically. So with Hello Web deployed, let's also deploy the first version of our greeter service. There you go. So the pods are initializing. We have 3 replicas of this as well. We're going to have 2 containers in there as well. There's an error here, but let's ignore that, and hopefully it'll come back. All right. Next thing that we're going to do is I'm going to deploy a gateway. So if you remember, gateway is the resource that's used with Ingress gateway, basically an Ingress controller, and it deals with traffic entering the cluster. So we're saying we're going to use a pod that's labeled with Istio Ingress gateway, and that's the Istio Ingress gateway. And we want to expose port 80. We're going to listen on port 80, and we're going to allow all traffic for all hosts, regardless what it is. So let's deploy this. I think, yep, I already have it deployed. Perfect. Just check on this. Yay, all good. Demo gods are on my side today. Perfect. So let's start with the second resource, which is called the virtual service. So we're deploying a virtual service for the Hello Web for the front end. We're saying that all hosts are allowed. We're also saying we want to attach a gateway to this service. So what this does is, this is basically a way of exposing this service to the public or through the ingress, right? So we're exposing it. And down here, we have the routes. So we're defining one destination. The destination's host is the fully qualified name of the Kubernetes service. And we're also specifying a port. This is where our stuff is running at. So we created the virtual service. And now I can show you the website. There you go. Looks very nice. There's a hello. There's a hand that's waving. You see over upper left corner, the service version is 1.0.0, same with the front end, so it's all good. So we have the first version deployed, and stuff is working. Nice. So I'll show Kiali as well. There was an awesome talk before me about Kiali, so let me show you quickly. So Kiali is the observability part of the service mesh. And we're going to use the graph here, and I'm just going to show you that I have a Hello Web here, version 1, and I have a greeter service, version 1. And then if we do some magic here to turn on traffic animation, which looks really nice, and I'm just going to start, it's going to start making requests to the service every 1 second, just so we can generate some traffic. Let me refresh here. It should come up soon. If not, I know a couple of good songs, so maybe I can sing. Oh, no, there we go. So there it is. Let's do traffic animation. There you go. It looks really nice, right? So the traffic is coming through the Ingress gateway. It's hitting the Hello Web service, and then Hello Web is calling the greeter service. All looks good. Now we're going to go and deploy the destination rule. And if you remember a couple of slides back, the destination rule is where we define our versions. So there's a part called subsets in the destination rule, and these subsets are basically used to define not necessarily just different versions, but I mean, not different versions in a sense of V1, V2, V3 version. You could also define your own labels and say, I don't know, I have a subset called prod, and that prod subset has a label called version 123, and it has a label called environment equals prod, and whatever you want to do. In our case, we just have two simple subsets, V1, V2, and each of those subsets has one label set to version, V1, and V2. So let's deploy this. Everything is still working as before. You see down here, there's still requests being sent. We haven't deployed the second version, so no changes at all. So next step that we need to do before we deploy the second version of the service is we need to make sure that all traffic is routed to the first version of the service. Because what you don't want to do is you don't want to deploy your second version and then expose your customers or your production traffic to a different version of the service. You probably don't want to do that. So what we're going to do here is we're going to deploy a virtual service for the greeter service, host. We're going to define two destinations here, and we're going to say the first destination is the greeter service Kubernetes service, and this is the subset called V1, and we want to route 100% of the requests or 100% of the traffic to that V1 subset. The second destination here is same host, same port number. The only difference is the subset is going to be V2, even though we haven't deployed it yet. And we're also saying we want 0% of traffic to go to that version. So let's deploy this. Down here, no changes, all is good. So now it's time to deploy the second version of the greeter service. So let me go here, clear. All right, show the pods. So the V2 greeter service is coming up. Should be up fairly soon. There you go. So this is the situation now. We have 3 instances of the front end. We have 3 replicas of the V1 version, and we have 3 replicas of the V2 version. Still notice down here, all the traffic is going through to the first version of the greeter service because that's what we told Istio to do. Let's quickly look at Kiali as well. I'm going to refresh here. And hopefully soon, we'll see that there's a second version. I think it should show up. Well, you have to believe me that it will show up eventually if it's not showing up now. All right, let's do the 70-30 split. So again, we're always updating the same virtual service here. We're not deploying completely new stuff. We're just updating existing resources. Again, virtual service for the greeter service. First destination is V1, and we want 70% of the traffic. Second destination is going to be V2, and 30% of the traffic is going to go to that version. So this is how you could do like canary deployments or blue-green deployments or A/B tests or all these nice techniques to bring new versions. So you've already probably noticed down here that there's a different response sometimes. Well, 30% of the cases, there's a different response. So if we go back, let's go here quickly. I'm going to refresh a couple of times. There you go. So this is our super duper V2 version of the service that has the fire emoji, and it's really nice. And you also see the V2 version here has changed. Let's go back here, and hopefully Kiali will cooperate. There you go. Perfect. So now you see that there's a V1 and there's also a V2 version of this service here. I'm going to quickly turn this back on, and I'll show the percentages. So there's a roughly 70-30, and again, this is math thing. I think if you send enough traffic to it, it will eventually be 70-30 or really close to it. So we have a 70-30 split, perfect. So at this point, what you could do is, if this was like real world and it was your actual V2 version of the service, you would probably fire up your Grafana and all your observability and monitoring magic and look at the logs and requests that are going to V2 service and make sure that there's no bugs. And once you're all ready, you're probably going to say, okay, so the V2 service is all good. We don't have any bugs. And finally, you could say, now we can go and say 0% of the traffic to the V1 version or V1 subset, and all the traffic to the V2 subset. So let's deploy this. And within a couple of seconds, you see all the responses are coming from the V2 version. I'm going to refresh a couple of times here. And Kiali will eventually refresh, and all the traffic would be flowing to V2 version, and this will basically become grayed out because there's zero traffic that's going to the V1 version. So this is really awesome. Let's show a little bit more complex demo, or, well, not a complex demo, but some conditionals. So there you go. So with this one, what we're saying, it's for a greeter service as well. And we're trying to match the header. We're trying to match the user agent header. And we're saying if the value in the user agent header matches this regular expression, which is a very, very simplistic regular expression to recognize an iPhone, then we want to route all the traffic to V1 version. Otherwise, we do another match and see if it's Android. Then we're going to go to V2. And in the last case, if it's neither Android nor iPhone, if it's desktop or something else, we're just going to go to V1. So let's deploy this. How many of you have iPhones or Androids? Yeah? Yeah, well, take your phones out. I need your participation now. And you have a chance to bring down my machine. So what I'm going to do is I'll quickly copy this. Go. There's a QR code. If you can scan it, it'll give you it'll take you to that URL. And if you have an iPhone, or if you have, oh, whoa, okay. Looks like it's working, I guess. I don't know. There's some 404s. So yeah, if it's Android, it should be V2, and if it's iPhone, it should be V1. Can someone confirm? Yes? Yeah? Perfect. Yay. The demo worked. Awesome. All right, I'm going to kill this. Otherwise, we're done. So let me just clean up this really quickly, and I'll go back to the slides. Just deleting everything. Perfect. Let's go back to the slides. So this was the traffic routing demo. Hopefully it's going to show up. There you go. Perfect. And guess what? Well, there's another demo. So this demo, I'll have 3 different services. I'll have the weather service. And the weather service is going to take in, I'm going to make a request to it with a zip code. And weather service will take that zip code. It's going to call the city service. City service is going to return city and state. I don't know why I called it city service, and then there's also a temperature service. We're going to pass in the zip code. It's going to return you the temperature. So let's show this as well. Go back. So we'll use the same cluster, same everything, same cheat sheet. So I'll quickly deploy all 3 services. There you go. There you go. So 3 instances of the city service, 3 instances of the temperature service, and 3 instances of the weather service. Let's do that. Let's wait for those to come up. Should be fairly quickly. Let's double check. Temperature service is lagging behind, but soon. All right, so we have all good, all green. Let's start making requests down there. So as you see, I'm just curling to localhost weather and 98052. That's the zip code from Redmond, Washington. That's where I'm from. So we get the city back. We also get the temperature back. We also get the zip code that we passed in, and there's a wind information here, but yeah, let's ignore that for now. So again, let's look at Kiali, and I also have, whoa, look at that. I have it here. Let's see. It should load up. There you go. Perfect. So as you see, there's 0 traffic to Hello Web. Well, the Hello Web is ancient history. We deleted it. There's a weather service, there's a temperature service, and there's the city service. So all is working, and it's not perfect if we don't turn on the animation. So now you actually see that the traffic is flowing. Let's also open Grafana. How many of you heard of Grafana? Yep. All right, perfect. Jaeger. The tool, not the drink. Okay. So let's do Jaeger. Let's open Jaeger. So Grafana is just a dashboarding thing, and all these dashboards here, I didn't have to do anything here. Istio is very nice, and it installed everything for me. So just a quick walkthrough to these dashboards. There's like Istio specific performance dashboard, which they don't make much sense for me because I'm running on my machine and I don't really care. Mixer. I mean, these are important, don't get me wrong, right? If you're running this in production, definitely keep an eye on these, but I'm running it on my machine, I don't care. And then the important ones are, if you look at the workload here, well, unknown, that's really nice. There you go. We get our weather service, our temperature service, and our city service. We also have the greeter service here because there were some requests that have been made before. So there's a bunch of nice stuff here, and this is all like 0 effort from me. I don't get any credit for this. I just installed it. So that was quickly just Grafana, and then Jaeger is the distributed tracing tool. So for Jaeger to work, there is a small piece of thing that you have to add to your services. There's a list of 7 magical 7 headers that you have to include when you're making calls from one service to another. And the reason you have to include those is to help Jaeger stitch all the traces together. And even with those 7 magical headers, it still sometimes doesn't work, but that's fine. Most of the time it works fine. All right, let's go back to the demo. So we're still doing the requests. I showed Kiali, I showed Grafana. So now what we're gonna do is we're gonna introduce a 6-second delay into the temperature service. So this probably looks familiar already. It's a virtual service for the temperature service. We have a single destination, which is our Kubernetes temperature service. And this is the important part. We are introducing a fault. Type of fault is a delay for 100% of the requests. And we're saying that the delay should be 6 seconds. So let's deploy this. And down here, should be seeing that it's actually taking 6 seconds for the calls to return. We're not going to wait here for too long. So I'll go back here. And there's a way to see this here as well. Might be workload, it might be service. So if I'm going to zoom into this one because it's really small, there you go. So these are the requests that I was making before on the left side. On this right side, you can see that P99 is already at 9.95. Again, don't ask me why it's 9 because it's a mathematical thing. But you can see that this is a considerable slowdown from what it was before. And similarly, If I go to Jaeger, and we're still looking at the weather service, we can specify a minimum duration for the traces. And we can find all the traces that took at least 6 seconds. So this is the one that happened a few seconds ago. So let me click on it. And over here, whoop, it should, there you go, perfect. So temperature service, and there you go. Exactly, I'm gonna zoom in because it's exactly 6 seconds. There you go, exactly 6 seconds, right? And that's the exact delay that we introduced with Istio through, and I can't zoom out now, through, is it here? Yeah, perfect. Through the virtual service. Yeah. Delay injection, this is important. The response flag, this is how you can actually see that the stuff was forcefully injected versus it was an actual delay that happened. So let's reset back because we're getting short on time. So I'm just going to reset back the temperature service. So just a default virtual service, nothing is set, just the destination. So temperature service should be back to normal. If we zoom in here, just so we can prove it quickly. There you go, you see it's already dropping and it's going to drop down back to the same values or similar values as it was before. And the next thing I want to show is introducing an abort into the city service. And we're going to introduce a 404 for 60% of the requests. Virtual service, one destination, which is our city service, fault abort percentage, 60%, HTTP status, 404. Let's do it. And you should be able to see down here really soon. There you go. So we're already getting back an error that says fault filter abort, and the service returned a non-200 code. Perfect, so it works. If we go back here to Grafana, we should be able to see in one of these graphs that there were some errors happening. Hopefully it's going to show up. Let's wait a little bit. And similarly in Jaeger, we could filter down all the traces that have the status code of 404. So I find them. There you go. This was a few seconds ago. And if we go here, city service, there you go. There was a 404, and there's an FI here in the response flags indicating it was a fault injection. Similarly here, hopefully it's going to show up. If not, I'll just move on to the different demo, or the last demo, I guess. Well, should be in one of these. Anyway, you'll probably trust me. I think I'm credible enough that it'll be a 404 there. All right, let's quickly reset this back. Set it back. And then what we're going to do is I'll just quickly show the timeouts and retries. I'm going to cheat a little bit because these are my services. I can cheat. I'm forcefully injecting a 2-second sleep into my service in the actual service itself. So anytime you're going to call it, it's going to take at least 2 seconds. And that's only to show the timeouts and retries. So, I should get better at copy pasting. Oh, there it is. Virtual service for the temperature service, same destination. And here we're saying timeout is 2 seconds. And we're also defining 3 retries. And we're saying each retry has a timeout of a half a second. So with the 2 seconds that we injected forcefully, we're going to do a first timeout. It's going to time out. And then we're going to do 3 retries. And each of those are going to time out as well, like in a half a second. It's going to wait for a half a second and it's going to fail. So there you go. Request timeout. We're already getting an error. And I'm going to quickly go to Jaeger. And this is where those magic headers are not so magic anymore because it's not stitching stuff together. But I'm going to refresh a couple of times. And there was one. I missed it. There we go. So there's one. So you can see that it was a half a second Right, this was one of the retries that was being made to from the weather service to the temperature service, and this is a response flag as well here. And let's go back. These were my demos. Hopefully this stuff will come back. Perfect. Thank you very much for coming. Thank you very much for listening. I hope you liked the demos. I hope you liked the talk. Feel free to ping me on my email. Feel free to follow me on Twitter. I don't have a lot of important things to say, but just follow me. And I don't know if you have time for questions or not, but I'll stay here for the next 20, 30 minutes, so feel free to ask questions.